Is it even possible that amino acids could have formed by chance? And if they could have formed by chance, is it even possible that proteins could have formed by chance? And even if they could form by chance, is it even possible that the simplest self-replicating cell could have formed by chance? And if that was even possible, what about DNA? What about RNA? We're going to talk about this today and so much more with Dr. Jonathan Sarfati. Welcome to the Youth Apologetics Training Podcast. Friends, welcome back. You know, we've heard from Dr. Sarfati many times before, at least a couple times before, and I know I've had him on a couple times, and many of you, he doesn't need an introduction, but if you're new to this podcast and you've never heard of Dr. Sarfati, he is quite the scholar. Very intelligent guy. Dr. Jonathan Sarfati, PhD, FM, was born in Ararat, Australia in 1964. He moved to New Zealand as a child, where he later studied mathematics, geology, physics, and chemistry at Victoria University in Wellington. He obtained honors in physical and inorganic chemistry, as well as in condensed matter physics and nuclear physics. And he received his PhD in physical chemistry from that same institution. Guys, and I've talked about this in the past, he's actually represented New Zealand in the Olympics playing chess. And he's a former New Zealand national chess champion. He's known for playing 12 different people in a game of chess at the same time, and get this, he was blindfolded. How about that? That's pretty amazing guy. So today we're going to be talking about the origin of life, exactly how I was talking about in the introduction of this podcast. Is it even possible that random inorganic materials could somehow come together in the right time, in the right way, and form that very first group of amino acids? Keep in mind, it's highly improbable to form one amino acid by chance, but we need to come up with a set of them that all have to be left-handed, because right and left-handed amino acids will combine and life cannot come about. You must have only left-handed amino acids. So is it possible that a group of just left-handed amino acids could be formed, and a large enough group that then somehow, through some miraculous event, a group of proteins formed by chance? And these proteins, again, totally improbable, in fact impossible, these proteins somehow come together to form that very first self-replicating cell. We're talking about all the information. We're talking about the DNA, the RNA, and everything else that is specified complexity, those things that we see about a cell. Guys, the cell has been compared to a space shuttle in that it's far more complex than even our space shuttles. And that's saying a lot, because you don't expect something like that to just pop into existence with a little bit of wind and rain and a few catastrophic events even. Okay, but we are to expect that somehow this amazingly complex, and we can even talk about the simplest of self-replicating cells coming about by absolute chance. And so that's what we're going to be talking about today with Dr. Sarfati. Dr. Jonathan Sarfati, welcome back to the Youth Apologetics Training Podcast. Dr. Sarfati, welcome to the Youth Apologetics Training Podcast.
Well, thank you very much for having me on.
Absolutely. The last time I had you on, my listeners absolutely ate it up. They loved it. And
so that's good to know.
Yeah. They've been asking me to have you back. So,
well, thank you.
Oh, absolutely. Thank you. And this subject has been one that I've been wanting to get into for a long time, and I wanted to find somebody who really had a powerful grasp of this subject, and that would be the origin of life. And
right.
Aaron Hughes with your ministry, Creation Ministries International, gave me a copy of Evolution's Achilles' Heels a couple years back, and I've been bouncing all over the place in that book. Recently, I took a vacation to Israel, and I was reading through it some more, but your chapter on the origin of life is just excellent. There's so much there that just clearly shows there's just no possible way that life could have originated by pure chance. There's just no way. And so I want to talk about a lot of things you brought up in that book. And of course, this is a book that you co-authored with many other authors. And friends, if you haven't picked this book up, it's probably the best book out there right now in the realm of creation and evolution that I've found. I mean, there's a lot of good titles out there, but this one, it's my favorite. Right now, it is by far, hands down, my favorite one. So you got to get a copy of this. And also there is a DVD that is absolutely just excellent as well. So check that out. Okay, so just jumping in, some evolutionists will claim that the problem of the origin of life is not a problem for evolution. What do you think? Is that a problem for evolution, and why?
Okay, let's first of all explain your readers and get the book and the DVD from creation.com. The book actually has 9 PhD scientists writing in their own specialist field of problems with evolution. And since I'm a PhD chemist, I wrote about chemical evolution and the origin of life. Now, the point is there are certain people who try to say it's not part of evolution, mainly because they can't explain it. But in fact, it has always been regarded as chemical evolution. The origin of life from chemicals is chemical evolution or prebiotic evolution. These are very well accepted terms. And if you go to almost any evolutionary book, they'll try to have an explanation of how life came to be in the first place. And it's a real problem for them because if you haven't got reproduction, you can't invoke natural selection to explain it. So, in fact, their whole Darwinian thesis is dead in the water because they can't get you to the place of mutation and selection and reproduction of the things selected for. So it's extremely important and what the atheists try to avoid.
And it certainly, I mean, as we're going to see, it's really a big problem. And so I can see why they try to push it away and say, well, that's not our concern. We don't need to worry about that. We just need to worry about how evolution took place after that.
Yep.
So in that struggle to show that the origin of life could have happened by random chance, there was an experiment called the Miller-Urey. Am I pronouncing that right? Miller-Urey experiment?
I think so, yes.
And they supposedly made the building blocks of life, amino acids, in this interesting contraption that they put together. And so can you talk about this experiment and how it was flawed?
Well, see, Miller was a graduate student of a very famous Harold Urey, who won the Nobel Prize for discovering deuterium. Now, they proposed that the Earth's atmosphere was once very rich in hydrogen compounds, and they thought energy flow, sparking, and ultraviolet could actually cause those things to combine into the molecules of life. So they tried to simulate that condition, but what they had to do is have certain traps to to capture those things as soon as they were formed, because if they left them going, they would be destroyed by the same energy that formed them. In fact, the destructive energy, forces are far greater than the constructive forces, as we'd expect. So it would be a very few of those things could ever survive such conditions, and also they're produced in such a way that they could never go any further. They're extremely dilute and contaminated, and when you try to make proteins from the amino acids, you have to purify them and concentrate them and have very special conditions before they go any further. So the Urey experiment does not produce the conditions for further development of these building blocks. They wouldn't build anything under those conditions.
Right. In fact, from what I have seen, it was just a small brown stain that they actually produced from this experiment, and this little brown spot had mostly tar that was toxic to life, and then the amino acids that it did make were both right and left-handed, and that is a problem as well.
Because, life has only the left-handed amino acids and the right-handed sugars in DNA and RNA. But the Miller experiment produced an equal quantity, which is what chemists will do. If they start off with something which is non-handed, they will get non-handed products or an equal number of left and right-handed. So again, life would not form from that because the mixture is just not suitable to build enzymes or to have a DNA double helix. So that is a huge problem. I know it from my own chemical research that it's very difficult to get the pure single-handed form. In fact, you have to start off with something which is already single-handed. And where do we get that from? Oh, from living things, of course. So we actually have to have living things to get the right amino acids for living things. But it's very easy to go the other direction of going from a pure left-handed to the 50-50 mixture, the racemic mixture. That's very easy to do. It's very hard to get it to where you want life to go. So again, the chemistry is going in the opposite direction of what's required.
Yes, and this part, I don't know if I've read this anywhere or not, but there's only 20 amino acids out of hundreds, correct, that actually can support life. Isn't that right?
Yes, the most living things use only 20 amino acids. There are a couple of things which use a 21st and a 22nd, but they're quite rare. But there's a jumble of things that could be produced which would not be suitable for life, definitely.
And the Miller-Urey experiment, did they produce all sorts of amino acids or only the ones that would be suitable for life?
Well, they didn't produce some of the ones that are needed and produce some of the ones that are not needed. And in fact, the biggest thing they produced was formic acid, which is basically ant sting. But if you wrote a paper titled, "Here's a new way of producing ant sting," you wouldn't get published, probably.
Okay, so they supposedly produced amino acids, and they did, but they didn't get all the ones that they needed. They had a chirality problem. Did I say that right, first of all?
Chirality, that's the handedness from the Greek word for hand. So the handedness problem is called the chirality problem, correct? Yes.
Yeah, so they produced right and left-handed, which is another major problem. The solution, or what they were produced in, was mainly tar, which is toxic to life. They also reduced the oxygen so that it wouldn't oxidize, correct?
Well, yes, because the sparking the current atmosphere would be hopeless because oxygen would actually break down any product. In fact, it would prevent the products forming, and any products that did manage to get formed would be broken down quickly. But now it seems that even the secular geologists are saying that the Earth's atmosphere always had quite a bit of oxygen in it. You've got certain chemicals which show there was oxygen around right at the beginning. There's just no evidence that the Earth's atmosphere was anything like what's in the Miller-Urey experiment. And they thought it must have been like the gas giant's planet atmosphere, but in fact you can't prove that geologically. Their geological evidence is against their atmospheric composition.
Okay, so interesting.
So and there's no evidence for a tar either. I mean, the thing is, if this thing was working, why is there no deposits of tar containing nitrogen in the geological record? If this has happened, where is the geological evidence that such a primordial soup or tar ever existed? It's not there.
That's interesting, too. I haven't heard anybody ask that question. And so even if we could have a situation where there was some type of a warm pond or gases that got an electrical charge, and there were some amino acids produced, and somehow they all happen to be left-handed, and the ones that are necessary for life, those amino acids now need to form into a protein. And what type of challenges do these amino acids now have to face in order for them to form into the simplest of proteins?
Well, the problem is that when the amino acids combine, they release a water molecule, so the process is called condensation. And the problem is the last place you want to do such a reaction is where there's water around, because water will support the reverse reaction, which is called hydrolysis. So any organic chemist who wants to make a protein tries to exclude water as much as he can. He certainly wouldn't do it in water, and in fact he'd go even further, not only have dry conditions, but have chemicals to absorb the water and drive the reaction towards the proteins. So having life beginning in a primordial soup, that's absurd from a chemical synthesis standpoint.
And then isn't there also a problem with these amino acids being able to fold correctly?
Well, you see, you've got the thing is, it's not just enough to get the right, even the right sequence is a problem, because if you just have a random mix, you will get a random sequence, and yet the enzymes required for life have a very precise sequence, but even that sequence is not enough because they have to fold in the correct shape, which is why we have proteins called chaperonins. Now, mad cow disease is from a prion, which is a protein that hasn't been folded correctly. So it's a very dangerous thing, and that's because of the deficiency in the protein folding mechanism. So you need to have that working for life to work, so the proteins fold in the correct shape for the jobs they have to do. But it seems chaperonin is a protein. How did you get the chaperonin folds properly before you had chaperonins to aid in the folding process?
And that's a big problem. Now, tell me this then, how many, on average, how many amino acids would it really take to make the simplest of proteins? And is that even something that could possibly even happen by chance?
Well, it could not, because even if you have a very conservative number of exactly required amino acids, the probability becomes way too small. Even if you had millions of years, billions of years, you had the whole universe to play with. When you do the mathematics, in fact, the probability is minuscule. And once more, you can't have natural selection involved because you haven't got reproduction yet.
That is correct. Yeah. So it's not like these reactions are going to be happening everywhere you look. If any of these amino acids are being formed, which we don't really see them forming by chance anywhere on Earth, even if they are forming, you still have to fold a specific sequence of them to even make one protein. Which right. There's how many amino acids, and you have to have left-handed only, folding in the right way, in the right sequence, and that's only to get one protein, and proteins don't even last that long once they've formed, to hang out and wait for the next amino acids to roll up and form another protein.
Well, I mean, when the simplest living thing has over 400 enzymes needed for life, and these are all very precisely made enzymes, and this simplest living thing is called the mycoplasma. It's a parasite, so this may not be complicated enough to survive in a primordial soup. It needs to attack things that are more complex than it to survive. So when I say 400 and so proteins, that's probably an understatement of what you'd need for a cell in a primordial soup.
And so you form this simple protein. You still have to put together a simple cell. How many proteins would it take to make the simplest of cells? And do you think this could happen by chance?
Well, I mean, it would take about 400 or so proteins to make even a simple cell. Then you've got to have the cell membrane to keep it in. So that's called, those are lipids or fat type molecules. You've got to have that, and you also have to have some sort of coding machine, because the cell, the proteins don't reproduce. They are made according to instructions in the cell's DNA. So you have to have a coding system for the proteins and a decoding system to manufacture those proteins according to the instructions. So I think a pure protein living thing just doesn't work, because it hasn't got the reproductive ability. You need both the reproduction and the metabolism. The reproduction is with the DNA and the RNA, and the metabolism is with the proteins, the enzymes.
Okay.
So both have to be there.
Okay. And then, should we get all the basic components of the cell, will we still have a problem with all the information, the DNA? Now, how in the world does DNA, how could you get DNA from the primordial soup?
Well, that's something that they don't even bother trying anymore. And just recently, in late 2015, they awarded the Nobel Prize for discovering that DNA was, in fact, very unstable. And so they won the Nobel Prize for discovering this, and also discovering what living things have to do about it, which means we have to have repair machines to undo this chemical instability. So without these repair machines, DNA could not last. And that's an interesting side note there, that we have DNA in dinosaur bones, and yet the science shows that DNA couldn't even last a fraction of the supposed dinosaur age.
Yeah, now that's fascinating to me. And they just keep finding dinosaur bones that have DNA, proteins, soft tissue.
Yes.
If they're millions of years old, you should not be finding that.
Yes, this is real science we're talking about. These are real observations of proteins and DNA, and real observations of breakdown rates. And the thing is, when it comes to the origin of life, DNA is just too unstable to last in a primordial soup, because you wouldn't have repair machines in a primordial soup. The thing is, but in living things, the instructions to build the repair machines are on the DNA, but unless you already had working repair machines, those instructions would be degraded, which would make worse repair machines, which would make worse instructions, and you get a complete collapse of the system unless you have repair machines and DNA almost perfectly coordinated right from the beginning.
Right, and those repair machines, without them, we have evolution in the wrong direction. I mean, we're getting worse and worse.
Yeah, so the thing is, DNA is so essential to preserve DNA to a very high degree of accuracy. Otherwise, life couldn't continue, because life requires reproduction of those instructions. And if you haven't got that accurate reproduction, because DNA is breaking down too quickly, living thing just can't work, can't survive, can't propagate.
Now, what about, DNA has very specific, complicated information about how much information is in the DNA, and is that even possible for that information to come about by some kind of chance?
Well, the thing is, you're talking about the information having to come out by chance, but also the instruction, the coding system has to come out by chance as well, because there's nothing in the actual chemistry of the DNA letters, you might say, to make them align in a certain way, and there's nothing to connect chemically, the DNA with the proteins that they code for. There's no chemical connection between the two. The only way you've got a connection is because you've got repair machines that make the connection, but there's no actual chemical connection between the two. So chemistry alone is just not going to do it.
And then we would also need some means of translating the DNA. Is that what you mean by coding, or?
Well, you've got the message that's coded, but then you transcribe, which means you put it onto a photographic negative of RNA, and that requires some machines just to do that step, and then the transcribed RNA goes to the ribosome, where it's decoded to make the proteins, and it's a very interesting, a really elaborate machine which does the decoding, because you need these decoding molecules called transfer RNA, which is a sort of adapter molecule between the RNA code and the DNA code. so all these things have to be working together so you can get this coding to work. And again, the DNA has the instructions for its own decoding machine. So which came first, the decoding machines or the instructions to build those machines, which can't be read unless you already have those machines?
Right. And that's a big problem. Okay, so none of this stuff so far that we've looked at, DNA, amino acids, proteins, chaperonins, it doesn't look like any of this could have come about by chance. There are some theories as to what got this ball rolling, and one of them is this idea of an RNA world. What is that, and does it even solve the problem?
Okay, first of all, RNA world, because they've discovered that RNA can have, there's very limited catalytic functions of RNA, so they're hoping that RNA could do a double job of both the coding and the metabolism, the enzyme work in one molecule. There's a lot of different problems with that, though. First of all, RNA is far more unstable than DNA. So I've already explained how DNA is too unstable for primordial soup, so RNA is completely preposterous. Now, a German biochemist working in New Zealand actually wrote a paper called Why RNA is the Worst Theory of Origin of Life, Except for All the Others. And so they got faith, but blind faith that chemical evolution's a fact, but all they can come up with is say RNA world's the only thing we have because everything else is even worse than that. But see, RNA, the building blocks are unstable. The building blocks are unstable if you have a warm temperature. That destroys the ribose and the adenine. So hydrothermal events would destroy the building blocks of RNA. It's under attack by water, hydrolysis again. And then you have to think about how you get the right handedness. You have to have right-handed ribose for the RNA, not left-handed. And it has to have a certain sequence. And just recently, after the book came out, they found that when you try to combine DNA and RNA duplexes, they're actually less stable still, you see. So the supposed intermediate state between DNA and RNA world and the current DNA world would actually be less stable. So if there's any selection going on, that would go against the intermediate step.
Interesting.
Many wrong things have happened. So you've got a bit of up-to-date information there because we haven't even written about that one yet.
Oh, interesting. Okay. You heard it here, folks. Okay. That's awesome. Okay. And you've already talked a little bit about chaperonins and their roles. There is another problem. Okay, some enzymes act as supercatalysts for some processes that are necessary for life. Without these enzymes, these processes could take millions to trillions of years. Can you talk about some of these super catalysts?
Okay, so the enzyme in general is a catalyst. That's why you have them in your detergents, because they help to break down some of the organic materials that we have. Now, the point is they are so efficient, they're so well designed, and that the protein actually has the right shape to incorporate the molecule it's helping to react, you see. So it has a little cavity or something like that, a lock and key thing, fitting a very specific molecule to do a specific thing to it. And sometimes it accelerates the reactions by an enormous amount, say 10 to the power of 18 or even 10 to the power of 21 times. Now, the problem is that they admit that these reactions are essential for creating the building blocks of DNA. Because if they were left to 78 million years in water, they would break down before they did their job, because you've got all the breakdown going on. So you have to have the reactions happening quickly before the stuff breaks down. But then, if this is essential for life, you cannot use natural selection to explain it. Even the discoverer, Richard Wolfenden of North Carolina University, he says this reaction is essential. You need this enzyme for life, and yet he says natural selection must have produced it, but he can't think how it could have done it. But the point is, natural selection could not have done it because you haven't got life before that. So natural selection cannot exist yet.
Right.
So it's a bit of a blind spot by him. So when you've got one reaction that would actually take far longer than the actual evolutionary Big Bang age of the universe, a reaction that would take 1 trillion years without the enzyme, but is done a fraction of a second with the enzyme. So again, you haven't got trillions of years to work on this thing. So again, he said this is essential for life. Therefore, you cannot use natural selection to explain it. But he seems to have that blind spot of trying to appeal to something which he cannot do. He's not allowed to do that.
Correct. Yeah, and the catalyst has to be there in the beginning, along with everything else that all happened to happen by random chance. It all has to be all in the same spot. And it all needs to be functioning together in order for anything to happen and reproduction to take place and for life to start. I mean, we're talking about a miracle.
Things, yeah. Well, it's almost what they have to appeal to. I mean, it's a miraculous chemical occurrence is all they've got. If they don't want to believe in a creator, that's all they've got. Because, as I say, they haven't got natural selection yet. So it's really a big mystery to them, and there's so many of these. You can multiply these problems for chemical evolution, which is no wonder they don't want to talk about it.
Right. Yeah, and so at this point, is it even remotely possible that this first life could have arisen by chance?
No. If any other area of science, they would actually reject it out of hand, but because the atheists need life to come from non-living chemicals, they are still trying to work out how it could have happened. See, with a lot of these researchers, it's not a case of whether it happened, it's how it happened. They've already made up their mind that it happened, because otherwise they have to believe in a creator. That's basically what it amounts to. They've already made up their mind that this has happened without actually seeing, is there a plausible chemical process for it to happen? No, they haven't got that. After decades of trying.
That's it's I guess kind of funny and tragic at the same time,
Yes.
It's too bad that they have ruled out the creator right out of the gates, and at that point you can't accept any alternative that has a designer included, and you have to resort then to some type of an event that's clearly a miracle. A miracle. We're now stepping outside of the natural and entering the supernatural for all these things to happen all in one place, all at the same time, with the perfect setting for this to happen, and then for it to somehow survive. That first little guy managed to make it, and he's got to survive to reproduce. It is a miracle, and there's no way it could happen.
It becomes an anti-science position, actually, because they're actually dispensing with real science and objective interpretation of the data, because they've got a worldview they've got to try and support.
That's tragic, and it's also interesting when I've got a brother who is got his PhD in neuro. Oh no, I'm drawing a blank. Anyway, he's a professor up at Purdue, and he runs a lab, and he believes lock, stock, and barrel in evolution, but it's not because he's seen the evidence. It's because he believes other departments, other people have. And I think a lot of that happens in academia, where people just believe, well, I'm not exactly sure. I've heard some of the evidence. I believe it because all the other guys believe it. And to not believe it is something that's frowned upon.
I think there are plenty of examples of that. We have, an expert in bird evolution, Alan Faducha. Well, yes, evolution's a fact. He doesn't believe the dinosaur bird, but he said, well, evolution's a fact because we've got corn turning into corn. That's evidence for evolution, which is, of course, variation within a kind. And you've got someone else who might say, well, the fossils don't show evolution, but the embryologists have shown evolution, haven't they? And then the embryologist said, well, no, Haeckel's a fraud, but haven't the geneticists shown evolution to be true? You see, they're all believing each other, ring around the evolutionary posy there. It's like ring the evolutionary merry-go-round, yet their own field doesn't confirm it.
Oh, man, that's terrible. It is terrible. So we breezed through these questions real quick. What else are you working on? What type of new things have you been doing? I see on your website. I'm sorry?
My latest book was actually a commentary on Genesis 1 to 11, completed almost 2 years ago now, but it's still my latest book. It's an 800-page commentary on Genesis 1 to 11. So it goes into why it matters for the gospel, how do the New Testament authors and Jesus understand Genesis, what does the Hebrews say, and some scientific support for why Genesis should be taken as history. So that's been quite an important book, I think, because there isn't another commentary like that, really.
No, there's not. And I have a copy of that, and I was hoping someday to talk to you about it. It
Sure.
is thorough. And I've actually used it. I've referenced it several times teaching at church.
Okay.
Yeah, because it's like a commentary, but it brings in a lot of the creation and evolution and so much more. It's just a really well done work. And you're right, there is nothing out there like it. In fact, friends, if you want to check that out, you can find it on Creation Ministries International on their website. If you click on store, of course, or you just creation.com. That's correct. Yeah. I'm always Googling things and not putting in the URL. Creation.com, and if you search for Sarfati or just jump in the store and start tooling around, you'll find it. Also, I'm seeing you've got a new DVD here refuting the new atheist. What is that?
Oh,
That sounds fun.
Well, it's going into the very popular people like Richard Dawkins and Hitchens and Dennett, and showing that atheists, by their own admission, have no basis for rational thought or for objective morality. Those are the sort of things. So yet atheists would like to call themselves rationalists and say Christians are anti-intellectual, yet they can't produce a reason to trust their own brain to be right. If it's a sort of an evolved monkey brain, why should they trust its own thoughts to be correct? So that's one thing. And then evolution is admitting if evolution is true, there's no such thing as objective morality, and yet they'll try and tell you that creationists are evil, but they've told us there's no such thing as good or evil. So which is it? They can't get their arguments straight.
Oh, that's fun. Yeah, they tend to be pretty aggressive, too. They're mean. They just get nasty. When you talk to you listen to some of these new atheists, and then of course you end up talking to some of their followers online, and boy, if you try to bring any type of logic or debate into the discussion, it goes straight to name calling right away.
Oh, very common with these people, because Dawkins especially is pretty good at it himself. The name calling, I mean. But he won't debate the best creationists or even the best Christian apologists. He picks on soft targets. They all tend to do that.
Yep, absolutely. What about this video, bioethics? What is this?
Oh, that was about things like how to think about abortion, stem cell research, human cloning, animal rights, euthanasia, from a biblical Christian perspective. Because I think a lot of Christians don't really know how to think biblically about these very important life issues. And sad to say, it's often the church is not teaching how to think through these issues.
Very true. Very true. It doesn't. It's few and far between when you find churches that are willing to address those types of subjects. You have to go out on the internet and be looking for these various para-ministries, these podcast ministries, and the like, who are willing to jump into that. I think. Well, I could speculate. I think that many of the the pastors out there are either afraid of the subjects because they haven't studied them too in depth, or they don't want to touch it because it might hurt the bottom line, which is tragic as well.
It is rather, which means that people in the church are not getting proper guidance.
That's
and
right.
Yet the polls showing pastors do believe that the Bible speaks to these issues, but they will never talk about it. Even though the Bible actually has very clear guidance on these issues. The Bible is very clear that the baby in the womb is a human being and therefore should not be killed. And so that's crystal clear. It's not a difficult issue. It's made to be a far more difficult issue than it really is.
That's sad. Yep. Well, guys, this has been Dr. Jonathan Sarfati. And yeah, if you want to know more about it, I probably did somewhat of a poor explanation of this book, Evolution's Achilles Heels. Yeah, it is. It's 9 PhD scientists explaining evolution's fatal flaws. It is fantastic. Every single chapter focuses on a different aspect of the debate, and it's an evolutionary slaughterhouse. I mean, it is so much fun to read through that book, and mine is starting to fall apart because it's been underlined and messed with so much, highlighted. Well, and it's been on a couple vacations too, but it's pretty beat up, and it's a really nice book too. It's got glossy pages. It does have some diagrams, charts, pictures. They're all glossy colored. It's just awesome. So I can't say enough about it. Excellent book. Dr. Sarfati, thank you so much for coming on the show. It has been an honor.
Again, I've enjoyed my time. Thank you.
Yeah, I've loved it. I've absolutely loved it. And maybe I can have you back on sometime and we can talk about your commentary. There is, it's a big one, but there's a lot of interesting stuff you bring in there. And maybe we can figure out a way to make that a 45-minute podcast with, well, there's just so much in there. That's the problem for me.
That, yes.
Very good. Well, all right then. I will let you go. And
okay. Well, God bless you and your listeners.
Okay, I'm going to stop right there. Yeah, it was a little shorter this time around, but there was a lot of good stuff that we talked about. Now, this is not the last time I'm going to visit this subject because there's actually a lot more. There is so much more of very challenging, if not impossible, scenarios or rather obstacles that random chance has to overcome in order to create that first self-replicating simple cell. All right. It's just impossible. It could not have happened. But we are taught this fairy tale in our schools as fact. And our kids are being led away from the Lord in droves because of teachings like this. And we need to push back. People need to know about this information. People need to understand just how impossible this really is. Because when you go to school and your biology teacher teaches this kind of stuff, he has never thought these issues through. Okay? He's never followed this road all the way down. And he's just teaching what he learned, and he's teaching it as fact. He may or may not have any malicious intent, but the fact of the matter, he's teaching lies. Or she. Okay. Anyway. And so this subject is not over. We're not going to stop here. It's just that this interview is going to stop right here. So friends, thanks for listening. Hey, if you like this podcast, I would encourage you to go up to iTunes and click the like button. Leave me a good review. Let people know that this podcast is out there. This is one of those ways that you can help spread the word about this podcast and get it out there. And so with that, I love you guys. We'll see you next week.
Sing it out loud, declaration.